Hello everyone, I am Rashmi Mandal Vijayvargya and I'll be speaking on the topic blockchain basics. So before we start with blockchain, let's discuss about different networks or systems. One is centralized, decentralized and distributed. As the name implies, in the centralized system, there is a central server which is going to control the entire network. So it has got its own pros and cons that we shall discuss in detail. In a decentralized system, the central server control is distributed or it is decentralized. And in a distributed network, the total control is distributed, that is, there is no central server. And all the nodes of the system, they have got the equal stake. So what is a centralized system? In a centralized system, all the users, they are connected to a central network owner or the server, and the central server will store the information about all the nodes which are connected to the central server. You can compare it with the example like you create your own email account. So entire information is saved into the server of the site that you have decided to make your account, say in Gmail or say in Google. Your data is stored in the Google account. The user information may include user profiles, user generated content and more, and it is easy to set up and it can be developed quickly. So what are the pros? It is simple to deploy, simple to develop, and it is also affordable and it is practical also. When you are very much sure that you need a central authority, then you can go for a centralized system. But definitely it is prone to failure. Why? Because if the central server, if it goes down, then the entire network will go down. It has got security and privacy risk also for the users because the entire data is maintained at the central server. So if the central server is hacked, then the entire information of the server will also be hacked. So all the users' data is also at risk. So you have to be very, very careful and you have to invest a lot of money in order to keep the system up. That is, the maintenance cost is very high. And second thing, since there is only one central server and all the nodes are connected to the central server, so distance also matters. Longer access times are there for users who are far away from the server. And scalability is also an issue in the centralized system. Why? Because it depends upon the capacity of the central server, how many nodes it can accommodate, how many nodes it can provide service to. Next is your decentralized system. As the name implies, in a decentralized system, it does not have any central owner. They use multiple central owners. As you can see from the diagram, also in our diagram, there are 3 central owners. And each of them, they store a copy of the resources that user can access. So it is not as vulnerable as centralized system, but yes, it is also vulnerable. But the thing is that if any one of the server goes down, it will not affect your entire system because other servers are up. So it will continue to provide data access to the users. So what are the pros? That it is, there are less chances of it to fail and it provides better performance and it is more diverse and more flexible. Scalability will also be more because it can provide more service as it can provide you the facility of connecting more nodes as compared to a centralized system. But security and privacy risks are still there because the entire information of the user, it is stored on these some or certain number of servers, and maintenance costs will be high because you have to structure the system in a manner that you have different centralized servers and the data integrity is maintained. So inconsistent performance when not properly optimized, this is also one issue with decentralized system. In a distributed system, as you can see with the diagram, it is similar to a decentralized one in that it doesn't have a single central owner, but it eliminates centralization as well. In a distributed system, users, they have equal access to the data. All the users, they are having the same privilege and they have the equal stake in the system. Like you can take the example of internet. So distributed system enables users to share the ownership of the data. And hardware and software resources are also allocated between users, which in some cases may improve the performance of the system. It is safe from the independent failure of components and which can definitely improve its uptime considerably. So it is fault tolerant. Why? Because if suppose there are 500 nodes in the system, if 100 nodes, even if they go down, the system will never go down. It is transparent and secure because everybody is enjoying the same privilege and have the equal stake in the system. And it also promotes resource sharing and extremely scalable. But it is very difficult to deploy and maintenance cost will definitely be high. Now we move on to what is blockchain. So in simple terms, we can define blockchain as a chain of data blocks which are distributed on hundreds or thousands of computers or servers. It is a complete ledger that maintains a copy of all the debit and credit transactions of a digital asset. It is a decentralized distributed ledger which tracks a digital asset on a peer-to-peer network. This peer-to-peer network is very, very important because when all the nodes they are connected to each other, we say that there is a peer-to-peer system where each node is having the equal right in the system, equal stake in the system. Blocks, they store information like time, date, amount involved. This amount is related to your transaction, sender and receiver information, previous block hash and current node hash. It is related, or the current block hash, it should be current block hash, and it is related to cryptocurrency, but it is not cryptocurrency. You should never confuse blockchain with cryptocurrency because blockchain is the platform, blockchain is a technology over which you are using cryptocurrency. Example, Bitcoin. It is a timestamp immutable chain of records. What does that mean? That is, once any transaction has happened and that has been recorded in a block and that block has been added to the blockchain, then it will never be deleted. You can always add the updates. Suppose if one of the transaction is not correct, then you can add one more block which will provide the information that that previous transaction was not correct. But you cannot delete any information. That is why it is an immutable chain of records. And it is managed by a cluster of computers and there does not exist a single entity. You can compare blockchain with bank passbook or agreement copy of any legal agreement. So what is happening in your bank passbook? In your bank passbook, all the pages are numbered and you are having the information right from the zero transaction that you did. So if you remove any one of the page of your bank passbook, then your information will be incomplete and it will be incorrect. So those page numbers actually they can act as your hash because each page number is related with the previous page number. Same thing is happening over here, that all the blocks they are related to the previous block with the hash of the previous block. If you tamper with any of the data in a particular block, so all the subsequent blocks they will be affected. So if we see a block overview, what is the information that is contained in a block? You have a block header and it is having a hash of previous block headers. You have a Merkle root hash, and it is, what is a Merkle root hash? It is containing all the block 1 transactions, block 2 transactions and block 3 transactions. In each of the blocks, this Merkle root it contains the block transactions. So block header contains what information? It contains block version, it contains previous block hash, it contains the Merkle tree root hash, contains a nonce value, and it contains a timestamp. Then you have the block body, which contains block version, and the Merkle tree root hash is a hash tree, or the Merkle tree encodes the blockchain data in an efficient and secure manner. It enables the quick verification of blockchain data as well as quick movement of large amount of data from one computer node to the other on the peer-to-peer blockchain network. So what is happening? The data itself is first hashed. These hashes are hashed again and merged finally, and the Merkle tree is merged into a single hash. The last hash is also known as the root hash, root of the tree. It represents the information of all its leaf nodes. So the transactions, they represent actually the leaf nodes of this Merkle root. And second thing that is to be kept in mind is that the Merkle tree requires even number of leaf nodes. So if suppose, let's go on to the next slide. Suppose this is the diagram of your Merkle tree where the root hash is actually being stored in your block of a blockchain. So you can see over here, this is the transaction A, transaction B, transaction C, and transaction D. So transaction A and transaction B, they are hashed, and their hashes are then combined to form a new hash. Same process is done for transaction C and transaction D. So transaction C is hashed to obtain hash C, transaction D is hashed to obtain hash D. Then hashes of C and D are hashed again, and finally these two hashes are combined together to form the root hash. But suppose consider a scenario where only 3 transactions were there. So what would happen in order to create the even number of leaf nodes, this transaction C would be duplicated. That is, transaction C hash will be hashed with the transaction C hash itself in order to create even number of nodes. And second thing is that the facility that this Merkle tree provides over here in blockchain is that you can download any one branch of this Merkle tree. It differs from a hash list, as in Merkle tree, one branch can be downloaded at a time and the integrity of each branch can be immediately verified even if the rest of the tree is not yet available. Now, if there is any requirement, suppose if the miner is mining a particular block of data and it wants to check whether a particular transaction is valid or not, which was coming from the previous blocks, then it is not required for the miner to download all the entire data. Only a particular branch could also be downloaded. But basically what happens, the miners are maintaining the entire data. At any instant of time, if you are any node in the blockchain, then you can also validate it. It is not required for each and every node which are part of the blockchain to have the entire data. You can only have the block headers downloaded into a system. The block header is actually containing the root hash information. So let's see how blockchain works. Now suppose someone has requested for a transaction and this requested transaction is broadcasted to a peer-to-peer network which consists of computers which are known as nodes. Then the network of nodes, they validate the transaction and the user status using known algorithms. This verified transaction can involve cryptocurrency, contracts, records or other information. Once it is verified, then this transaction is combined with other transactions to create a new block of data for the ledger. The new block is then added to the existing blockchain in a way that it is permanent and unalterable. Then the transaction is completed. This is the entire life cycle of a block in a blockchain. That is, the whatever transaction has been requested, it has to be first validated, and this validation process is done by a miner with a set of agreed algorithms. Like there are proof of work, proof of stake, which involve in proof of work a cryptographic puzzle is to be solved, and all the miners, they are competing in order to solve that cryptographic puzzle, in which they have to guess a number so that they obtain a hash which is in terms of predefined structure, right? So the one miner who is able to do it first would be the winner, and the miners are getting a reward. So next is centralized or decentralized blockchain. We have already seen the centralized system, decentralized system, and a distributed system. We can say that blockchain can either be centralized or decentralized, but inherently it is distributed in a manner that all the nodes are distributed in different locations, because the distributed concept comes from location, right? So whether a blockchain is centralized or decentralized simply refers to the rights of participants on the ledger. In a centralized system, the known entities will only be allowed to be a part of the system. That is, the blockchain will not be made public. That is a private blockchain. So you can also argue then how it is a blockchain. But you have to learn more about it. And first, we should be aware of what are the basic things in blockchain. So in a blockchain could be private or public depending upon the requirement. Large organizations, they can have blockchain for their requirements. And in a public blockchain, it is available for all, like Bitcoin. It is publicly available. All the ledgers, they are also publicly available. On an insecure network, your data is moving, but in a cryptographic manner, all the data is encrypted and cryptography is used so that the data, it is secured. In a private blockchain, the way the data is mined, the concepts only change, but it is controlled by a central authority, and only those who are allowed to add information to the ledger, those are the entities which are decided by the central authority. In a decentralized network, anyone can participate and transact on the ledger. As a result, mechanisms must exist in order to combat the vulnerabilities that arise from this design and to ensure the transactions are correct. For example, in Bitcoin, it is a decentralized network. As I told you, it is a decentralized blockchain that uses mining and proof of work to maintain the integrity. And proof of work involves solving the cryptographic puzzle by the miner. The miner who solves the cryptographic puzzle first is the winner and gets the reward. In a centralized network, on the other hand, it is made up of parties or identities who are known, and the system is valid because only credible and reputable participants are allowed to post the ledger. So this requires further more explanation, which we will discuss later. So I hope this session was explanatory. In this session, we have discussed about what are centralized system, what are decentralized system, what are distributed system. Then we had seen the pros and cons of these systems, how they are applicable to blockchain, that also we have seen. Then we have seen how a blockchain works, what are the parts of a block, what is Merkle tree and what is Merkle root hash. Thank you.